We need to discuss another one of our foundational objects in geometry, and there's a lot to talk about, so we're just going to jump right in. So that first object, or that new object, is the angle. So an angle is just two different rays with the same endpoint. So it's not really anything new. It's just going to be an object that's actually built from objects that we've already had. So this is the example here. I've got an angle. It's two different rays that have the same endpoint. This right here is a side, and so is this. And then the vertex is this point right here. So those are my parts of the angle, two sides and a vertex. And the way that I name them is kind of in the same way that I name rays to begin with. So to refer to a ray, I need the endpoint and the point on it. And so to refer to this angle, what I'm going to call it is by a point on the side, so in this case A, and then the vertex B, and then the other side C. So I write that as angle ABC. Now that's not the only way I can name this. Another way that I can name this is by going the other direction, angle CBA, just as long as I make sure that this point in the middle is the vertex, and then the points on the other sides are the sides. There's one additional way that I can name this, and that would be just calling it angle B. But I can only call it angle B if it is unambiguous as to which angle I am referring to. And what I mean by that is that when I call this angle B, there's no other angle that I could potentially be referring to. An example of that would be if I had another ray in here, and I had this point labeled. If I talked about angle B in this situation, I wouldn't know if I'm talking about angle CBA or ABD or DBC or which angle. It's ambiguous as to which one I'm referring to. So another way of saying this is that I can only call something angle B or call it by that vertex point if there's only one angle stemming from that point. So that's the definition. We can build off that then to talk about the protractor postulate. So the protractor postulate, it's another one of these real basic ideas. So if we remember what postulate means, it means one of these real basic facts that we're going to accept without proof. And what it says is that the measure of an angle is the absolute value of the difference between the real numbers associated with the two sides of that angle using a protractor. So what we mean is that if you've ever seen a protractor before, what it looks like is this half circle, this semicircle, where I have the angles labeled. So this would be 90 degrees up here. This would be my starting point at 0 degrees, 180 degrees over here. Somewhere in between, this would be 135. This would be 45, and so on. And so what it means is that if I have an angle that's centered here at the center of my protractor, that the angle itself, its measure, will just be the absolute value between the two real numbers associated with the two sides. So in this case, if I have this down here at 0 degrees, and let's say this goes through at, this is 60 degrees here, so the difference between these would be 60 minus 0, the absolute value of that, which would be 60. So this is 60 degrees angle. So basically, it's the exact same thing as the ruler postulate that we had for segments, but it's just basically saying that we can give measures to angles using a protractor. That's all it is. So let's move on to talk about the angle addition postulate. So again, it's another postulate, and this one's really hard to give words to. So we're actually going to do a little bit of a drawing. So if I have, 3 angles total. So if I have 3 angles here, I will call them, this will be A, B, C, and this will be my vertex D. So if a point, in this case point B, lies within the interior of this angle, angle ADC, it will be the case that the measure of angle ADB plus the measure of angle BDC will add to be the measure of angle BDC. So one thing that I should have gone back and said before is that when I want to talk about measure, the way that we do that for an angle is when I actually talk about angle ADC, this is referring to the points themselves. If I want to refer to the measure, I'm going to use the measure of angle ADC. This actually is going to be equal to a number in this case. And so it'll be the case that if B is on the interior of angle ADC, the measure of angle ADC will be equal to the measure of angle ADB, plus the measure of angle BDC. So this is again very similar to the segment addition postulate. That just tells me that, hey, if I have these two angles here and together they make this larger one, then the two measures should add up to be just the measure of the whole. And that's all the angle addition postulate says, is I can add angles together and their measures will be that of the larger angle that they make up. So that's my last postulate. And then I have a few more definitions, I believe. So my next definitions would be congruent angles and angle bisectors. So congruent angles are two angles that have the same measure. So just like we had congruent segments, we can have two angles that are congruent. And so the attribute that they share in this case is their measure again. So if I have two angles, if I want to talk about angle A and angle B, if I want to say that their angles are the same, okay, the measures of them are equal, I can say that the measure of angle A is equal to the measure of angle B. I could also say, since their measures are equal, that angle A is congruent to angle B. And so again, equality here means that two things are exactly the same. The numbers that measure angle A and measure angle B are, so let's say they're like, 45 degrees, those values are exactly the same. Congruence, on the other hand, means that their attribute is the same. In this case, we're defining that to be that they have the same measure. And so congruence here means the same thing that it does for segments as it does for angles. It means that the two objects have the same measure. And just like segments, again, we have an angle bisector. And so a bisector just divides an angle into two congruent angles. And specifically, it says angle. This should be ray. That's embarrassing. Okay, this should be a ray that divides an angle into two congruent angles. So if I have an angle here, this is a pretty good angle. I'll call this one angle, what if I not use C, D, and E. I can have a ray that bisects that angle, F, if it makes two congruent angles. And this is how we mark angles congruent. We use these little arcs, or sometimes we'll use two arcs, but that tells me that two angles are congruent. So an angle bisector is just a ray that divides an angle into two congruent angles. So last but not least then, what we need to talk about is actually classifying angles by their measures. So there's four different classifications of angles. The first one would be acute angles. Let's go back to this. So we have acute angles, and these are angles whose measures, so if we talk about, let's say this is we're talking about angle A here. Talk about angle A. So this would be if my measure of angle A is less than 90 degrees but greater than 0. And then we also have obtuse, which is probably one you've also heard of before. And this is when this angle here, the measure of angle A, is greater than 90 degrees but less than 180. And the third one you probably also have heard of is called a right angle. And this is a very specific measure. This is when the measure of angle A is equal to 90 degrees. And the last one you may not have seen before is called a straight angle. And what a straight angle is a specific angle measure, so measure of angle A, when it's exactly equal to 180 degrees. So, a couple of things to emphasize here. The measure of angle A equaling 180 degrees, so a straight angle, what that means is essentially that my angle is a line. So for example, I could talk about this angle here, angle ABC. It's a straight angle if it makes a line. So that's one important thing. And then acute, obtuse, and right, I'm pretty sure you'll be fine with. One thing that we do have to point out, though, is these inequalities. These inequalities are super important here, okay? Because a lot of times I'll ask you a question like, what is the largest acute angle that I can have? And a lot of times students will give me the answer of, oh, the largest acute angle that I can have is 89 degrees. And that's just not the case. We're just thinking about integers here, but what about 89.5 degrees or 89.9 degrees or 89.99 degrees? And so this will go on infinitely. It'll never stop. And so it's really important that I talk about this inequality here, because there is no largest acute angle. I can just keep making them slightly larger and slightly larger and slightly larger. They'll get closer and closer at 90 degrees, but there is no maximum. And so I don't want to talk about the fact that the acute angles are anything, in between 1 and 89. What I really need to talk about is the fact that they are less than 90 degrees and greater than 0 degrees. The same thing goes for obtuse angles. There is no least obtuse angle. Anything greater than 90 degrees will be obtuse as long as it's also less than 180. So these inequalities are really important for me here. Right angles and straight angles are easy because they're only the one value. So that's the introduction to angles. They basically have a lot of the same properties of segments where, if we have something for segments, we probably also have it for angles. And the only new thing here is the classification. So that's something that'll get us started, and we can build from this going forward.